Ever since I first saw one of these unique Goodwill vices, I've wanted one. I've searched everywhere, but I just can't find one, so I reckon the next best thing is to try and make one. I've made a 3D model on the computer and I'll quickly show you its features before I start making it. It swivels on the base, just like lots of vices do, but it also tilts forwards and backwards. But the best bit is that it also rotates the jaws around this tubular support. This allows it to be set in just about any position and making it very versatile. Anyway, let's get into it, and I'll start by making this support tube which houses the main screw and holds the jaws. I was going to try and use thick wall tubing, but I couldn't find anywhere that stocks it locally, so instead I'll bore out this piece of EN36 steel. I'll turn down the outside first to the final dimension. I've never bored anything of this length before, so it's all new to me, and in fact there's quite a few new things that I've never tried before in this project. I've only had my lathe for about 2 years and the milling machine for about a year before that, so before then I'd never done any machining. Hopefully it shows that you don't need to be an expert to have a go at something like this. I'm certainly not. I reckon it's all about just having fun and giving it a go. I'm going through the drill bits, going up in size slightly each time and setting a good speed for each drill bit, and I'm boring in from one side. I'll cut that off and then bore in from the other side. I also have the lathe set up in 3-phase now with the VFD, and that makes it super easy to set the speed. That's bored out now to halfway through the bar to the final dimension, which is 25mm or 1 inch. I'll just clean it up, part it off and turn it around and do the other side. And while I do that, I'll explain why I've set the lathe up in 3-phase. The cheap and pretty poor motor on it are packed up. The supplier informed me that it was out of warranty, even though it isn't that old, and you'd expect that a motor would last longer than that. Fortunately though, Gamaco Artisan Supply saw a post that up on Instagram, and they stepped in and offered me a new motor and VFD to not only get me up and running again, but to upgrade the machine at the same time. They're great people who support the maker community, and I need to give them a big shout out for helping me out. I've also made a separate video on installing that motor and VFD that you can find on my second channel if you're interested. That's bored out, so next I'll make a recess in the end, and that will be for the head of the main vice screw to sit in. It needs one more feature before I can take it out of the lathe, and that's a groove on the side, and that will become more apparent what that's for later on. That's the first procedure done. It's looking pretty good. The inside the bore isn't perfect, but it doesn't need to be. Next I'll put it in the milling machine and I'll mill out a slot. The nut for the main vice screw will ride inside this tube. There'll be a flat section that goes through this slot, and that will connect to the rear jaw. There's a lot of work on this project, but that's the first part done, and I feel like I've got over a hurdle. Next I'll start working on the main vice screw, and for that I'm using this Acme threaded rod. I need to give a big shout out to New Weld who sent it to me, and you would have seen me use some of their products like these awesome clamps in some of my past videos. There's two parts to the main screw. There's the Acme threaded rod itself and then the head of the screw. I'll turn a tenon on the end of the threaded rod and that'll fit inside the head. For the head of the screw, I'll use the leftover piece of EN36 that I used on the support tube. Over the last few months in my workshop, I've been working on and testing a new product, and now I'm proud to announce Bondi Bond, my very own CA glue. I've been using it in all of my projects with just about every type of material: wood, metal, plastic, or anything else that you can think of. It comes in 3 different thicknesses, which extends its use across many varied situations. The thin Bondi Bond is ideal for wicking into gaps and thin joints, or even stabilise soft material by soaking right into it. The medium is perfect for a general all-round adhesive. The thick Bondi Bond is great for filling voids and knots and repairing fix-ups. and I like to use it to quickly put together jigs along with the activator, which sets the bond in just a few seconds. I reckon it's a great product. Hopefully you'll give it a go, and as always, thanks for your support. The head of the screw only partially goes into the support tube. In between that and the back of the recess, there's a spacer and a washer, which I'll make next. The nut doesn't quite fit inside the bore, it needs turning down. It's imperial, it's an inch, and inside the bore is just slightly less than an inch at 25mm. I'm using a second nut to hold that nut tighter on the screw while I turn it down. That really feels like it's starting to become something. Next, I'll take this piece of mild steel, I'll mill that down, and that's the flat bit I mentioned earlier that connects the nut to the rear jaw. Even though I have a design to work to, I haven't 100% worked out how I'm going to make everything. I'm working a lot of it out as I go, and I've decided that I'll tack weld these two pieces together. The first thing I'll do though is mill a flat on the back of the nut. I prepared the weld joints off camera just by grinding on some bevels, and then I can fill those up with a weld bead and grind them off afterwards. I'll put it together and try it out, and the steel washer that I made earlier, I've remade that and I've done that from brass. Now I'll put it together, and I'm actually putting the nut in the wrong way around, but that doesn't matter, I'll sort that out later on. For the screw to work nicely, it'll need some pressure on it from a spring. That reduces the backlash, and I'll make all the pieces for that next. This spring won't be strong enough, but it's the right size, so I'll use it for now and I'll replace it later on. Next I need to drill a hole through the screw, and that's for a piece of brass rod to go through, and that'll hold all those pieces together. I made a simple washer off camera that will slide on that collar and push up against the spring. As I said earlier, that spring will definitely need replacing, it's nowhere near strong enough. Next I need to stop the spacer from turning inside the tube. I'll do that with a couple of screws, and everything else there, including the screw, can turn freely. I really enjoy trying to recreate these old tools and machines as well, like the die filer that I recently made with a couple of mates. If you have any ideas of what I could tackle next, then definitely share it. I'd love to hear your thoughts. The M3 grub screws are quite tiny, but that's all that's needed to stop that from rotating. The original vise had nothing in there at all. It was just quite a tight fit, and when I say quite tight, not an interference fit, because this needs to be removable. That's the vice screw mechanism done. I've got the nut in the wrong way around still, even though I do know which way it goes. The spring, as I said, is a bit soft, but it's good enough to show that it's doing its job and it's working correctly. Next I'll start making the jaws, and I'll do that from this piece of steel. I'm not sure exactly what steel it is, but it is free machining and it's from a local CNC workshop. It's only just long enough and there isn't much held in the jaws, so just to avoid any sort of crash, I've put a couple of clamps to use as a carriage stock. This piece also needs to be a tube, so after I've turned down the outside, I'll bore out the centre again, and that will fit around the support tube that I've already made. I drilled it out to 25mm, so next I'll use a boring bar and bore it out further. I won't go to the final dimension though, because I've got to weld a piece to the outside of this and it may distort, so I'll bore it out afterwards. You can see here that it doesn't quite fit, which is exactly where I want it. And you can see here the piece on the drawing. Next I need to make the jaw piece that fits onto it, and I'll do that from a piece of 2" by 2" mild steel bar. I've highlighted the jaws on the drawing just to give you an idea of the shape that I'm trying to create. There's quite a few curves, but there are some flat surfaces as well, so I'll do those first and I'll do that on the milling machine. I've milled it all the way around. I did leave one face which isn't needed, and next I'll mill a recess, and that's for the jaw plates to sit in later on. Next I'll mill a recess that's half round, and that will sit across the top of the tube, and then I can weld it on. I thought of different ways to do this, but I decided to use the rotary table on the milling machine. Well, that wasn't good. It obviously wasn't secure enough. I almost got all the way through it, just left this section which I'll file off and then have a think about how I'm going to finish it. I reckon the clamp was just far too thin, and I did see that it was bending, but I thought it'd be okay, so I've just beefed that up and made another one. Okay, let's give it another go. Fingers crossed it works this time. After that first mishap, I'm really taking it easy and I'm taking light cuts. It's taking longer, but I'm in no rush. Another way I could have done it would be to tack weld a temporary piece to it, then do a full bore and then zip those welds and the second piece back off. I'm using the vac as I go and it's keeping the work area clean, but the main thing is it's keeping the chips away from the cutter with less chance of it binding up. After I've finished a cut to full depth, I unlock the table, move it over a touch and then lock everything back down again. I probably could take deeper cuts than what I am. The carbide cutter actually works better when it's cutting deeper, but after that mishap I'm taking it easy. As the cut gets wider, it's cutting into the clamp, but I'm confident now that that clamp's going to do the job and everything will be okay. That fits well and I could weld it on now, but first I'll do some shaping. I'll glue a paper template on. I'm using thin Bondi bond to do that. I'll mill away some of the waste areas first and then finish it on the belt grinder. I thought about cutting away a section first on the bandsaw, and I even considered just grinding the whole thing, but this carbide end mill cuts so well. The only thing is the chips get very hot, so I decided to put on a welding glove. It's actually a pretty good way of doing it because it keeps everything square across the piece, and then the square corners left from the end mill are perfect guides to grind down to later on. I'm loving the Broadbeck grinder. It's an awesome machine. If you're looking for a grinder, then I definitely recommend this one. It has heaps of accessories and that makes it super versatile. It's a super smooth machine and it has heaps of power. That's the outside of the jaw done. Now I need to do the same process but on the inside. Here's one of the awesome accessories for the grinder. It is actually a knife making attachment, but all these add-ons are useful in so many different ways and this is perfect for this job. I just need to remove these last couple of areas either side, then I can weld it together. I'll glue the template on and that'll give me a guide to grind to. I've rounded over a piece of plywood so I can sit the jaw on it and keep it upright while I grind it. Even with the workpiece getting hot and wet, the Bondi Bond holds the template on very well. You should be able to see that off camera I've beveled the joints ready for the weld, and that's a good thing to do anyway, but a lot of the weld is going to get ground off later on. This part and others in the project would have been better off casting, and that's something I'm definitely going to do and I'm hoping to do it very soon, but anyway it just shows that it's possible to fabricate these pieces one way or another. That looks like a good solid weld. I will grind it later on, but next I'm going to finish that internal bore. I put it in the 3-jaw chuck just to see how concentric it is and it looks pretty good to me, so I'm going to go for it and bore it out. If it wasn't concentric I would have put the 4-jaw chuck on and indicated it in. There's a fair bit of stick out on the boring bar, but it needs to be because the front of the jaw is protruding so far. It is a carbide boring bar though, so it's very rigid and that gives me a decent chance of still getting a good bore. That's a good fit and it does need to move freely, so I'm happy with that. Next I need to cut a keyway in that internal bore, and that's for the nut to sit in, which will get bolted to it. The first thing I need to do is line the jaw up in the vise. I'm just doing that by eye and I think that will be plenty good enough. I'll lock the quill and then I'm going to have a go at broaching the keyway. It's something I've never done before. I've made this cutter and we'll see how it goes. That's working very well and it's super satisfying. I'm nudging the table over a very small amount each time and it's cutting with ease. I'm really enjoying that and I can't believe that the cutter only took about 20 minutes to make and how easy it is. That's looking pretty good. I'll just check the measurements and then if it's okay I can take it out of the vise. That's looking good, so let's see how it fits. I'm super happy with that. Next I need to bolt the two pieces together, and I'll do that with 3 countersink machine screws. It's just a simple job of drilling through holes on the jaw piece, and then I'll transfer those holes onto the nut and thread them. These adjustable parallels are super handy. Here I'm using them to gauge the height across that piece that I've got clamped to the nut, and that will make sure that it's square in the vise. I could have positioned the middle hole better. It's right on the edge of the nut. It'll be fine, but if I'd have moved it back, I could have actually gone into the nut, which would have made it a bit stronger. I need to shorten the screws to a certain length, so I've made this jig which I can use on the lathe, and that will make sure that all the screws are exact and consistent. That's working pretty well, and I have a moving jaw. It is a little bit tight. It's not too bad, and maybe some oil in it would be enough, but I've decided that I'll fine tune it a little bit more. I didn't do too much. I just polished it up a bit, and that made it much better. So next I'm going to replace that spring with a stronger one. That's working much better, and I'm very happy with everything so far. I do need to grind these welds over, but I'm going to make the front jaw first, and then I'll grind them both at the same time. The two jaws are different, but there are some similarities, so I'll try and get through some of it a bit quicker. I welded a second piece on, and I did that from the sides while I machined this face, but now I need to machine down the sides, and I'll end up machining those welds off, so I need to re-weld it across the front. I really should have gone out and got another piece of steel big enough to make it out of one piece, but I'm just using what I have, and I think this is going to work out fine. I'm milling down to just over the final dimension, and putting those grooves in there and filling them with weld I think will be plenty strong enough. Also, a small vise like this is never going to be used to crank down hard and try and manipulate or bend something, even though I'm sure it probably could. It's just a small vise for holding small parts. I'm just finding centre, then I'll use a centre punch to mark it, and then I'll use that with a live centre in the tailstock of the lathe to line it up. Before I put it in the lathe though, I just need to remove these corners as they're going to get in the way of the jaws of the chuck. Where I need to drill is right on one of those welds, and a regular bit just isn't getting through it. In the past I've used the sharpened masonry bit to get through hardened steel, so I'll try that next. That did the trick, so next I can use a boring bar and open it up further. Before the motor went on the lathe, I had it securely bolted down to the floor. I haven't sorted that out yet, and because this piece is unbalanced, the lathe is shaking around a little bit, so I'm having to run it slow. I could add some extra weight to try and balance it out, but it's cutting okay, so I'll keep going. I'm using the DRO to get the correct measurements, but I am directly checking it as well now and again. It doesn't need to be a super tight fit, but I want it to be a half decent fit. It's starting to look a bit like a vise, maybe a funny sort of looking vise, but anyway, next I'll start shaping that front jaw. The next procedures are very similar to the rear jaw, so I'll try and get through quickly. As I said at the start of the video, I've searched everywhere for one of these vices and I'd still really like one, so if anybody knows of one that's available, I'd love to hear from you. Now that I've got the general shape on that front jaw, I'll start rounding everything over, including the welds on the rear jaw. I took quite a bit off that one side trying to streamline it and get a nice shape. Now I just need to do the other side to match. They're starting to look great, but I'll do a bit more refining just to clean them up and finish them off. I'll fix the front jaw onto the support tube later on. I'll do that with retaining compound, but I will do it with one bolt as well, so I'll drill for that first. I'm tapping while I've got it in place, but I'll knock off the front jaw and then drill a through hole through that piece. Now that I have that screw, I realise that it can go through to the spacer, so I don't need the M3 grub screws anymore, so I can take those out and just use that one machine screw. I just need to drill out the spacer again to accept the new screw. If I haven't already said, I'm really enjoying this project, it's so much fun. Anyway, next I'm going to drill a hole through the head of the main screw for a Tommy bar. The Tommy bar is stainless steel, and I'll also make a couple of end caps from stainless steel as well. Before I fix those, I'll add some weld to the front face of the screw just to fill in the gaps and tidy it up a bit. I welded it off camera, but you can see me machining it off here. That looks much better, but there's a problem. Off camera, I put the whole thing together just to test it out. It was the first time I put any real pressure on it and it broke off. To fix it, I'll machine a clearance on both the head and the end of the screw, and that'll give me plenty of space to get a good weld bead around the joint. I was always going to weld this end of the screw, but at that point of the project, I think I just started steaming ahead, and I thought at the time that it looked fine as it is. I also wasn't thinking about drilling through for the Tommy bar at the time. Anyway, it's all fixed now, so here's a test, which is exactly the same as what I did when I broke it. I did put a fair bit of pressure on it to test it out, and it's probably a good thing that it failed then and not when the project's finished. Now I can fix the caps on the Tommy bar. The last thing to do on the vice section is make some jaw plates, which I'll make from these scraps of aluminium. I'll also make a spare set so I can have one set that can get dinged up and one set that I can keep clean. Now I just need to drill and tap into the jaws. Before I put the vice back together again, I made a bronze washer to fit behind the spacer, and that will allow it to turn more freely. They fit just about perfectly, and that's the vice section complete. So next I'll make a leg, which will later connect to the base. I'll make that from a piece of mild steel, and it doesn't sound that interesting a piece, but there's actually quite a bit to it. Halfway through I cut into the wrong face, so I had to start again. I wasn't paying attention as I was thinking ahead and what I'm going to do next. Next I'll bore it out for the main vice support tube. I'll mark out the centre, then line it up in the 4-jaw chuck on the lathe. That's a good fit, not too tight but not sloppy, so next I'll bore out a recess, and that's for the front jaw to sit in. Next I need to finish the recess on the milling machine. The corners will need rounding off, but I'll keep it square for now. That's this bore done, so now I need one running the opposite way through the side of the block. I've decided to do this on the milling machine with the rotary table. I'll start by drilling and threading a hole, which will be for clamping the leg to the vise and also to the base. Now that's done, I'll lower the head and mill out a feature which will be for the base to pivot on. The slot needs to be wider than the cutter, so it'll need 2 passes, and I've decided to cut the outer diameter first. Before I cut the inside diameter, I'll mill away these sections first. It needs a bit taken off the height, but that feature is done. Now I need to flip it over and mill a recess on the other side. It's looking good, I just need to tidy up these edges. Now for an interesting task, cutting a slit through the block and into the bore. I don't have a slitting saw deep enough, so I've made an arbor for a metal cutting circular saw blade. I'm confident nothing can go wrong, but a crude guard seemed like a good idea. It cut very well and it was just big enough. Now I can round over the corners. I could do this on the rotary table, but it will be easier and quicker to just grind them, and they aren't critical as long as they look pretty good. It clamps to the support tube well with very little pressure. Next I need to add a spacer to locate into the groove on the tube and keep the leg in that position. I'll use a grub screw, but I need to machine a tenon on the end to sit into the groove. The leg doesn't quite sit up to the jaw, it contacts underneath the arch section. It just needs a bit of rounding over and then it will fit. I really enjoyed making that part and it turned out great. Next I'll make a screw to clamp the leg to the vise. To tighten the screws, I'll be using a Tommy bar, so next I'll drill cross holes through the head of the screw. I'm chamfering the first one to a depth that I like and then set the DRO to 0. I then do all the rest of them to that setting. I could set up a stop, but I don't like the stop on this machine and it takes too long to set. I made a screw for each side of the leg and a third one ready for the base. Next I'll start a piece that connects the leg to the base and I'll make that again from mild steel. I'll try and get through this piece quickly but still show all the steps. Thin Bondi Bond is awesome for gluing on paper templates. It soaks straight into the paper and using the bottom of the bottle to flatten it out is optional. It really is all coming together. I just need to make the base and I'll make that from this piece of mild steel flat bar. There's two pieces and the top piece needs to be a disc. I'll roughly cut that out and then turn it on the lathe. There's a few features to this part. The first is a shoulder which will fit into the other piece of the base. Next I'll turn it around and cut a large chamfer and then shape it. I've removed it from the temporary arbor that I had it mounted on so I can drill out the bore to the final size and then turn a recess. I need to flip it back over again and make a recess on the opposite side. That's the top piece done. Now I need to machine the bottom piece for it to fit into. I didn't have the perfect tool to do this, so I just walked my way in with the tools that I have, and it worked out pretty well. The bore is a little off center, but it still needs boring out to final size, so it's not a problem. I didn't get the footage of boring that out, but I did, so now I can tap the threads. That's working very well, so next I'll flip it over. I'll make a recess on the back for a foot, just so the whole thing sits better on the workbench. I'll square up the bottom piece to the final dimensions, and I'm using the knob to reference the distance away from the cutter and to keep all four sides the same. I'll radius the corners on the belt grinder, and while I'm doing that I'll round over all the edges as well, and then I'll drill out the mounting holes. Next I'll countersink the holes, but I don't have a 16mm countersink bit, so I'll do it with the drill bit. The angles aren't quite right, so I'll finish it with a 12mm countersink bit, and that will get enough engagement on the bolts. That's the base just about done. Next I need to connect the leg to it, and I'll do that by milling out a pocket and then welding them together. I was going to weld the underneath, but I decided not to. I don't think it's needed, and there was more chance it may warp, so next I'll start cleaning up those welds. There'll be comments about how dodgy the welds are, but they're perfectly fine. They're easily strong enough, and it really wasn't that easy working around those clamps. Anyway, it's time to assemble it and have a look at it all together for the first time. I reckon it looks awesome, so next I'll try it out. I'll clamp it down to the bench. I'm just doing that with one bolt just to see how it works. I reckon it's pretty cool, all the different positions it can go in, and I think it's going to be super handy. One thing I'm finding are the bolts are quite hard to undo, so I've made some brass washers and that should fix that problem. That was an easy fix and it works much better. Next I'll start cleaning down all the pieces, ready for some finish. I'm degreasing and masking up just the parts that I'm going to paint. There are some parts that I'm going to nickel plate later. I'm using an etch primer first, and then I'll put some colour on, and that will be a hammer finish. I'm super happy with the finish and the colour as well. I did put a bit of filler in around those welds. So anyway, next I'll start cleaning down, ready for the nickel plated parts. I've shown this a few times in past videos. It's electroless nickel plating. It's very easy to do. You just have to get the solution up to the right temperature, make sure the parts are clean, and leave it in there for 15 minutes. Also, I should point out that it's not just a good finish and prevents it from rusting, it actually makes the surface harder as well, which is perfect for some of these parts. I've decided to make a washer to go between the two pieces of the base and help it pivot better, and I'll do that with a piece of thin K&S brass sheet. So that's all the parts laid out. It was a lot of work, so let's put it together and see how it looks. The first thing I need to do is attach the front jaw to the support tube, and this will be a permanent fix. To do that, I'm using retaining compound as it's not a super tight fit, and the reason for that is I didn't want to force these pieces together because I always knew they were going to be finished differently and I didn't want to mess up the paintwork. It is a small vise and it obviously has limitations, but for a lot of work that I do, I think it's going to fit in perfectly. I'm really looking forward to any feedback on the vise and also the video as well. I think it's the longest video that I've made, and I did think about making it into a multi-part series, but I never like to do that. If I had done, I could have had a video out a few weeks ago and a couple more in between as well. I'm not sure what you think of that, but it'd be interesting to hear your thoughts. Anyway, I think it's coming together really well. It's been a lot of work, not just making it, but the design as well. I've gone backwards and forwards. I've made changes, made tweaks here and there. And in the end, I think it's come out fantastic. And there it is, all finished. I do need to mount it to the bench, and I'm going to use it on this workbench, but I want to figure out a way that I can remove it or put it on easily. I made a Tommy bar just by cutting off a piece of stainless steel, and I'll do another quick demo of the whole thing, even though you've seen it countless times now and you have the idea what the vise does. It's one of the most fun things I've made. I reckon it's awesome and it looks great too. Hopefully you enjoyed the video. Don't forget to check out the Bondi Bond, and as always, thanks for your support and I'll see you on the next one.